Okay, we're going to look at number 9 here. It says use the grid to draw 3 different rectangles so that each has an area of 12 square units and they all have different widths. They want to know what the dimensions of the rectangles are going to be. So we need 3 different rectangles on here. Now, what's important is you know area equals length times width, right? And we need the area to be 12 units, square units. That means these, your length and your width, have to be factors of 12, multiplied to get 12. So you need to think of the ways that you can make 12. In order to do that, if I were you, I would think about doing maybe a factor rainbow. So like 1 and 12. You could go 2 and 6, and then you would have 3 and 4, right? So those are all my factors of 12. Now dimensions just means length and width. So what would the length be? What would the width be? And they're saying you have to have different widths. So I can see here one way I can do this is having a 1 by 12 rectangle. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, here, this column. So rectangle 1, I could say 1 by 12, and that equals 12 units squared. Then I could say the second way is to do a 2 by 6. So if I went over 2, 1, 2, and then up 6, and I shade that in 2 by 6, that's another way that I can have 12 square units. So that's 2 by 6, and that's also 12 units squared. And then the last way, I could look at 3 by 4. So if I have come over 3 and I go up 4 and I shade that in, there's my other rectangle, and I would say 3 by 4, that's also 12 units squared. So in order to define that, I'm just using my factors of 12 to find the square units there to get the different dimensions and the different rectangles that are 12 units in area. Now, number 10 is the same thing. Okay, only it says Brandon has 32 stamps. He wants to display the stamps in rows with the same number of stamps in each row. Okay, how many different ways can he display the stamps? So you're going to do the same thing with 32 that I just did with 12 and figure out, like, okay, so like if it was 12, I could have 1 row of 12 stamps, or I could have 2 rows of 6 stamps, or I could have 3 rows of 4 stamps. Or I could have 4 rows of 3 stamps, 6 rows of 2 stamps, or 12 rows with 1 stamp in each of them. So you need to figure out all the different ways that you can display those 32 stamps using the factors of 32 for number 10. So you're on your own for that one. So you should pause the video now. Pause. And work on your factors of 32 and figure out how many different ways you can do that. Okay, here we're talking about the prime factorization. So this is different than just listing factors. Remember, so now we're dealing with the prime factorization of each of these numbers. So with each of these numbers, I don't care if you use the ladder diagram, like that looks like a birthday cake, or if you do the factor tree, but you have to find the prime factorization of each of these, okay? I will do 891 for you. So how I would look at this to start is I would say, I remember my divisibility rules. And I would say 8 plus 9, that's 17. 17 plus 1 is 18. So I know for sure, I can start with 3, right? Because 18 is divisible by 3. So I'm going to start with a factor tree for 891. So then, and you can use your calculator for this. That's totally fine. So in your calculator, you can take 891 divided by 3. Oh, that's 297. Okay. Now, I know 3 is prime, so I'm going to circle it. Now you have 297. Well, 9 plus 7, that's 16, plus 2 is 18. So I know that's also divisible by 3. So I'm going to do that. I'm going to circle my 3 because that's prime. In my calculator, I'm going to take 297 divided by 3. That's 99. Okay, well, 99, you should know that 11 times 9 is 99. 11 is prime. 9 is not. Then I can break 9 down even further to 3 times 3. So then what I'm going to do is I'm going to count my 3's. I have 1, 2, 3, 4 of them. So that's 3 times 3 times 3 times 3 times 11. That's 3. I have 4 of those to the 4th power times 11. So my final answer is 3 to the 4th times 11. So that's how you would do that with the factor tree. Now, if I was going to do 891 with the ladder, again, I would start with 3. 3 goes into 891 297 times. Then I would say, oh, I'm going to use 3 again. 3 goes into 297 99 times. And remember, I have to have a prime number outside on my birthday cake every time. Whoops. Then I'm going to use 11. 11 goes in 99 9 times. Okay, then I say 3 goes into 9 3 times. Then 3 goes into 3 1 time. Now I'm done. So again, I would have this 3 times 3 times 3 times 3 times 3 times 11. That's 3 to the 4th power times 11, the prime factorization of 891. So that's both ways, using the ladder method. And remember, prime numbers have to be used on the outside. You can't just use any number. Or I personally like the factor tree better than the ladder method for this, but you can use whichever you prefer to finish 13, 14, and 15. Okay, so now we have this problem, and it says 2 is chosen. 2's prime, right? 2's chosen to begin a ladder diagram to find the prime factorization of 66. So 66, they start with 2. They want to know what other numbers could have been used to start this ladder diagram, and how does starting with a different number change it? Well, the first thing I would do is I would start with a 2 and see what I get, right? Like what other numbers will I end up using? Well, 2 goes into 66 33 times, right? So now I'm at 33. Well, now I could say 3, right? 3 goes into 33 11 times. And now I'm at 11. And that goes in once. So when you look at what I have here, you should then be able to tell what other prime number you would be able to start, or prime numbers you would be able to start this ladder diagram with. And how does that change the diagram if you start with a different number? And the only way to tell that is to pick one of those and do it, right? It would only take you a couple minutes to try that out. So you're going to finish up 16 on your own. All right. So 17. Oh, so you should pause the video and finish number 16. Also here, you should have paused and done 13, 14, 15 on your own. Hopefully you did that. If not, you should rewind and do that. Okay, here they want us to list 5 numbers that have 3, 5, and 7 as prime factors. So you should be able to get this one manipulating your numbers a bit. So I'll give you 2, and then you need to get the other 3. Okay? So first of all, the easiest way to do this, first of all, is to take 3 times 7 in your calculator, and you get 21, multiply that by 5, and I get 105. So 105 has those three numbers definitely as prime factors, right? Because I just multiplied them all together. So that has to be one that has all of them. Well, then, if you look at this, it's also easy to see that this ends in a 5, so it has to be divisible by 5. Also, 1 plus 0 is 1, and 1 plus 5 is 6. 6 is divisible by 3. Therefore, 105 has to be divisible by 3. And then I would just check 105 divided by 7 in my calculator. And that works too. So that is a number that would have all three of those as prime factors. Okay? Then another easy way to do that would be like, okay, I'm going to take 105. I'm going to multiply that by 10. And when I do, I get 1050. Again, using divisibility rules, 1 plus 0 is 1, plus 5 is 6, plus 0 is still 6. 6 is divisible by 3, therefore 1050 is divisible by 3. Also, 1050 ends in a 0, so it's also divisible by 5. Then, in my calculator, I would take 1050, divide that by 7, to check that. Oh, that also works. Okay, so there's 2. So if I were you, I would use this one and work with it, manipulate it, or even this one, to try to find 3 more. So you need 3 more that have those 3 numbers as prime factors. Okay, so you're not asking you to prime factor it, you're just finding 3 numbers that have those numbers as prime factors. Now, this one would also have 2 as prime factor, right? 1050 also would have 2 because it's an even number. So, you know, there are more. So you're going to pause and find 3 more. Okay, and then this one, in a game, you draw a card with 3 consecutive numbers on it. So that means that you have 3 numbers in order, like 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. You choose one of the numbers and find the sum of its prime factors. Then you can move that many spaces. You draw a card with the numbers 25, 26, 27. Which number should you choose if you want to move as many spaces as possible? Okay, so what it's saying is you have to draw a card, okay? You choose one of the numbers on it. You find the sum of its prime factors. You move however many spaces it is with the sum of the prime factors. So what you're going to have to do is take 25 and prime factor it. You're going to have to take 26 and prime factor it. You're going to have to take 27 and prime factor it. Then you're going to have to add up those prime factors. For example, 25 is going to be 5 and 5, right? Well, if I add those together, I'm going to get 10, so I get to move 10 spaces. Okay? Now 26, you'd have to prime factor that. Then add the prime factors like I did for 25 to get how many spaces you would move. Same with 27. Okay? Then you need to say which one you would choose so that you can move the most spaces as possible. Does that make sense? Okay? So you're going to pause the video and finish working out number 18. All right, number 20. Explain why it's possible to draw more than 2 different rectangles with an area of 36 square units, but it's not possible to draw more than 2 different rectangles with an area of 15 square units. The sides have to be whole numbers. Now I'm going to give you a hint here. You need to use all factors, all factor pairs, I should say, for 36 and 15 when you're explaining. This is very much like that first one where, you know, we had the area with 12 units and then the next problem was like the stamps with 32. Same thing. Okay, so you need to think about your number 36 and 15 and why 36 would have more than 2 possible rectangles and 15 would only have 2. Okay, so there's your hint. So you're going to pause the video and do number 20. Alice wants to find all the prime factors of a number when you multiply 17 times 11 times 13 times 7. She thinks she has to use a calculator. to perform the multiplications and then find the prime factorization of the resulting number. Do you agree? Why or why not? So my hint here is look at these numbers first, okay? That should give you a big clue. What kind of numbers are those? Okay, look at those numbers. And then you should be able to answer 21 pretty easily, I think. And then here we have Ryan wrote the prime factorizations shown below. If he continues this pattern, what prime factorization will he show for the number 1 million? Okay, so if 5 times 2 gives you 10, and then 5 squared times 2 squared gives you 100, and then 5 cubed times 2 cubed gives you 1,000, then 5 to the 4th times 2 to the 4th, now you would think that should give you 10,000, right? So you should check that with your calculator, see if it's true. So then that's adding on, that's going up one place value. So then going up another place value would be what number? And then going up another place value would be what number? And then going up, how many place values would you need to go to get to 1 million? And then what exponents would that be? And then what would it be for 1 billion? Okay, you should be able to figure that out pretty easily using the exponents and the place value. Okay, and that's your last one. Okay, then you should ask her to check it, and I will see you guys on Monday. I hope you have a great long weekend. Thanks for working hard today.